Hello everyone. First of all, I'd like to express my gratitude to our Professor Dr. Dipali Jat ma'am for giving me this opportunity and providing support to complete this assignment. Let me introduce myself. I'm Nikita Verma, a student of BSc final year at Dr. Hari Singh Gaur University, Sagar. The topic of my presentation, as you can see on the screen, is Metchnikoff and P.Ehrlich experiment on the role of phagocytosis. What I intend to do is describe to you about the contributions and experiment performed by Sir Metchnikoff and Sir Paul Ehrlich on the discovery and role of phagocytosis. I have divided my presentation into three main parts. First of all, I'd like to give you an overview about phagocytosis. Next, I'll focus on experiment performed by Metchnikoff and discovery of phagocytosis. Lastly, we will talk about Paul Ehrlich's side chain theory to explain antibodies or antitoxins. So, first, let's discuss about phagocytosis. What is phagocytosis? Have you ever wondered how a virus or other infectious agents invades our body and what our immune system responds to it to protect our body? There comes the term phagocytosis. The word phagene means to devour, kytos means cell, and osis means process. Phagocytosis is a process by which certain living cells called phagocytes ingest or engulf other cells, particles, or foreign particles. In higher animals, phagocytosis is chiefly a defensive reaction against infection and invasion of the body by foreign substances. Phagocytosis is a critical part of the immune system. Several types of the cells of the immune system perform phagocytosis, such as neutrophils, macrophages, dendritic cells, and B lymphocytes. Mechanism of phagocytosis is very specific and depends on the cell being able to bind to the item it wants to engulf by way of cell surface receptors. Phagocytosis won't happen unless the cell is in physical contact with the particle it wants to engulf. Next, how does phagocytosis happen? Phagocytosis occurs after the foreign body, a bacterial cell for example, has bound to molecules called receptors that are on the surface of the phagocyte. The phagocyte then stretches itself around the bacterium and engulfs it. Now let's move on to the next part. Here we will talk about the man and his contributions due to which we are able to know about phagocytosis. Metchnikoff. He was a Russian zoologist born in 1845 and died at the age of 71 in the year 1916. Best known for his pioneering research in immunology. Honored as the father of innate immunity, Metchnikoff was the first to discover a process of immunity called phagocytosis and the cell responsible for it called phagocyte, specifically macrophage. This discovery turned out to be major defense mechanism in innate immunity as well as the foundation of the concept of cell-mediated immunity. Metchnikoff made his original observation in 1880s while studying invertebrate marine organisms. Leading up to the experiment, Metchnikoff was studying ways starfish and sponges digest food and was following the life of motile cells in a transparent starfish larva. When he noticed cells that moved from place to place throughout the carcass, they moved by sticking out one part of themselves and dragging the rest of themselves after that part. He called them wandering cells. He then introduced thorns under the skin of starfish larvae as transparent as water. He observed that special cells attacking small thorns. After studies of starfish larvae in 1882, he pointed to phagocytosis as one of the immune system's ways of operating. By this he meant that certain cells in the blood, white blood cells, work by encapsulating and destroying harmful bacteria and other microorganisms. Next is Paul Ehrlich and his contributions on the role of phagocytosis. Paul Ehrlich, born in 1854 and died in 1915, was a German physician, serologist, and immunologist. Based on his research, he is considered as the founder of chemotherapy. Ehrlich presented a chemical theory to explain the formation of antitoxins or antibodies to fight the toxins released by the bacteria, while Metchnikoff studies the role of white blood corpuscles in destroying bacteria themselves. By that time, most scientists agreed that both explanations of the immune system were necessary. Early in his career, Ehrlich began to develop a chemical structure theory to explain the immune response. He saw toxins and antitoxins as chemical substances at a time when little was known about their exact nature. Ehrlich supposed that living cells have side chains, a shorter chain or group of atoms attached to a principal chain in a molecule. These side chains can link with particular toxins. According to Ehrlich, a cell under threat from foreign bodies grows more side chains more than are necessary to lock in foreign bodies in its immediate vicinity. These extra side chains break off to become antibodies and circulate throughout the body. Thus, a small amount of toxin could produce a larger quantity of antitoxins able to neutralize the adverse toxin effect on normal cells. Lastly, in the year 1908, both Elie Metchnikoff and Paul Ehrlich received the Nobel Prize in Physiology or Medicine for their contributions. This is the end of my presentation. Thank you.